Well, this is Pearson Edexcel International Advanced Level, Jan'20 2020. Mathematics, Mechanics 1. Question 1. Two particles P and Q of mass M1 and M2 respectively are moving on a smooth horizontal plane. The particles are moving towards each other in opposite directions along the same straight line when they collide directly. Immediately before the collision, both particles are moving with speed u. The direction of motion of each particle is reversed by the collision. Immediately after the collision, the speed of q is 1 over 3 u. A part, find in terms of m2 and u the magnitude of the impulse exerted by p on q in the collision. So, the solution, part A. P and Q, M1 kg, M2 kg. This is P and Q moving towards each other, U with the speed U and U. After the collision, the speed of Q is 1. So the direction of motion of each particle is reversed by the collision. Here is 1 over 3U. The first part is find in terms of M2 and U the magnitude of the impulse by B on Q. So for this, I can consider any particle. Okay, let us consider this Q because on Q. So here is the impulse. Impulse is obviously in this direction when they collide. Impulse, as we know, is a change of momentum. So relative to Q, impulse is, I've drawn this towards right. 1 over 3U is towards right. So after this, M2 into 1 over 3U minus, before is M2 into minus U because U is in the opposite direction to I, the direction of I. So when you simplify, 1 over 3 M2U plus M2, and when you simplify, you can take LCM or you can take common 1 over here is these were the like terms 4 over 3 M2U is the impulse exerted by P on Q. Part A. Second part is find in terms of M1, M2 and M2, M1, M2 and U the speed of P immediately after the collision. Let after the collision Vp is the speed after the collision. As mentioned there that after the collision, motion, the direction of motion of each particle is reversed by the collision. So Vp is question mark. By conservation of momentum, momentum before collision is equal to momentum after the collision. So This is before and this is after. So momentum before is equal to momentum after. So let us take this reference as the positive. So before is m1 u plus m2 into minus u because coming from the opposite direction is equals to after is m1 into minus vp because our reference is rightwards and vp is drawn in the leftward direction. So this is minus vp and 1 over 3u is towards right. So m2 into 1 over 3u. So simplifying m1 u minus m2 u is equals to minus m1 vp plus 1 over 3 m2 u. So question is to find vp. So I can shift m1 vp on the left hand side. So this implies m1 vp is equals to moving the terms on the right hand side 1 over 3 m2u plus I can write this first m2u minus m1u. I can take LCM or I can simplify like this. The first two are the like terms and I can simplify, and this is 4 over 3 m2u minus simple basic mathematics simplification. And next I can take LCM of the right hand side. So m1 vp is equals to 4 m2u minus 3 m1 over 3. vp is finally, so in the numerator we have this is m1u. So u is common in the numerator. I can write u the common 4 m2 minus 3 m1 over c is there, so divide by m1. So this is the speed. Question was to find in terms of m1, m2 and u the speed of p immediately after the collision. So this is the speed of p immediately after the collision. So we have the answer to part B. C part. Hence show that m2 is greater than 3 over 4 m1. So as this is the speed and speed is always positive, so vp is greater than 0, u 4 m2 minus 3 m1 over 3 m1 is greater than 0. U is positive and 3 m1 is positive, so you can cross multiply and 0 is there. So this implies 4 m2 minus 3 m1 is greater than 0. And shifting 4 m2, shifting 3 m1 on the right hand side and dividing by 4 is 3 over 4 m1, and this is wanted to prove. Show that m2 is greater than 3 over 4 m1. 3 over 4 m1. Yes, this is the result. So question number one. Question number two is yes, moments. A uniform, a non-uniform beam AB has the length 6 meters and the weight W newtons. The beam is supported in equilibrium in the horizontal position by two vertical ropes, one attached to the beam at A and the other attached to the beam at C. CB length is given as 1.5 shown the figure. And the center of the mass of the beam is 2.625 from A, as it is non-uniform. So 2.625. So center of mass is here. This is the center of mass. I can mark it here. The center of mass is 2.625. 2.625 meters from A. The rope is modeled as light strings. The beam is modeled as a non-uniform rod. Given that the tension in the rope attached at C is 20 newtons greater than 20 newtons. So attached at C is 20 newtons greater than the tension in the rope at A. So let at A the tension is T newtons. If it is T newtons, the tension here, T newtons, then it is 20 newtons greater. So write T plus 20. So the tension, I have marked the tension. So I follow the condition. The tension at C is 20 newtons greater than the tension in the rope at point A. Find the value of W. Find the value of W's first part for 6 marks. State how you have used the fact that the beam is modeled as a rod. This is for 1 mark. So W, find the value of W. So for the W, as this beam, your non-uniform beam is in equilibrium, and before starting the solution, let us find the length this side. So as the total is 6, this much is 2.625, 1.5 is here. So when you subtract the sum of 1.5 and 2.625 from 6, we have the distance of C from this point. So this is G, the center of gravity, center of mass, and 1.875. 1.875. Now, equilibrium, for equilibrium, what you can do, this is part A, as equilibrium, so upward force is equal to downward forces. The upward forces are T and T plus 20. So plus T plus 20, the sum of upward forces equals to sum of downward forces, which is W, is equal to W. So 2T plus 20 is equals to W number 1. Next, for the next as equilibrium, so you can take moments. So you can take moment about any point. So let us take G. So taking moment about G. Moment about G. So as equilibrium, so anti-clockwise equals to clockwise moment. So for G, relative to G, we have one is clockwise, the other is anti-clockwise. So this is about if G is the point, this is anti-clockwise, and this would be the first is clockwise, the other is anti-clockwise. So t into the distance from the center of gravity. So t into 2.625. 2 into 6, 2 t into 2.625 is equal to an anti-clockwise t plus 20 into this distance. T plus 20 into 1.875. So from this equation, I can find the value of t. Let us simplify. 2.625 t is equals to 1.875 t. Then 20 multiplied by 1.875 is yes 37.5. 2.625 t minus 1.875 t is equal to 37.5. Simplifying, 2.625 minus 1.875 is 0.75. T is equals to 37.5. So 37.5 divided by 0.75 is the value. T is equal to 50. Question was find the value of W. So you put this value in 1. 1 is 2t plus 20. 2t plus 20 is equals to W. 2 into t, the value which you just calculated, 50 plus 20 is equals to W. So 100 plus 20 is equals to W. W is equals to 120. Question was to find the value of W. Yes, W is value is there, 120. Second part was state how you have used the fact that the beam is modeled as a rod. So beam is modeled as a rod. B part. Rod means the beam remains straight, means it does not bend. You can say mean straight, or you can write beam is rigid. Anything you can write. Beam is rigid. It does not bend. So this is the thing which is the uh, fact which we've used here. There's no bending in it. Question number 3. Particle P is projected vertically upwards with speed u from a fixed point O at the instant when P reaches its greatest height h above O. A second particle Q is projected with speed 1 over 2u vertically upwards from O. Find h in terms of u and g is the first part. Find h in terms of u and g. A particle P is projected from O. U is the initial speed, and moving up the highest point. So I can draw, so this is point O. This is point O. and particle is projected from O. This particle is P. P is projected from O with U. So for A part, let us discuss the motion of P. Initial is U. At the highest point, so height h reaches the height h above the ground. So at the height, this is the highest point, and at the highest point, v is 0, and at the highest point, the height is h. So I can use a different color. This is h, and project it with u. So let us write the data here. Final is 0 at the highest point, and at the highest point, to reach the highest point, the distance traveled is h. As moving up, so acceleration is g, which is 9.8, which is 9.8, the value of g, acceleration due to gravity. So this is minus g because moving up. 2as is equals to v square minus u square. 2 into minus g, you don't need to write this value because the question is in terms of u and g, so just keep g as it is there. So this is the value. So minus g into h is equals to v square, which is 0, which is 0 square minus u square. Minus 2gh is equals to minus u square. And this negative goes with the negative, and we have the value of h in terms of, so this is u square over 2g. This was the first part. Show that the maximum height reached is u square over 2g, first part. Okay, find h. So this is the height in terms of u and g. Find in terms of u and g the time between the instant when q is projected and the instant when the two particles collide. Find in terms of u and g the time between the instants when q is projected. So q is projected. So over here it's written there that particle q is projected when the particle p reaches the greatest height above O. Q is projected with 1 over 2. So I can just, for the understanding, I can write here. Again, this is the position O. So this is the position O. And from the same point, for the understanding, I'm drawing it on the right side, 1 over 2. This is Q. The same, this is again a point O, and this is particle Q. This particle Q is projected when P reaches the maximum height. Find in terms of U and G the time between the instant when Q is projected and the instant when the two particles collide. Well, find in terms of U and G the time between the instants when Q is projected. When Q is projected. . Let T is the time taken by Q. Time taken by Q. So during this time, the particle P will be moving in the downward direction. Because when the particle reaches the maximum height, uh, particle Q is projected. So this is during this time it is coming down. And eventually the question is find the time when they collide. So when they collide, so they will collide. If I draw it here, it is moving up, coming down. T is the time taken. So and they will collide. Let T is the time taken by Q. This is the time taken by P uh, during downwards motion. So here I can start with when the particle P reaches the maximum height and it's coming down. So in that case, so the motion of P. And next I can discuss the motion of Q separately. So motion of P and motion of Q. From the highest point, it is coming down. So initial is 0. Time taken is T as coming down. So expression due to gravity is G. And here I can use S, say S is SP. So S equals to UT plus half AT square. SP is equals to 0 plus 1 over 2 GT square, or SP is equals to 1 over 2 GT square. Motion of Q, initial is 1 over 2 U, time is T, moving up, minus G is the expression due to gravity, and this is SQ. Again, I can use UT plus half AT square. So SQ is equals to 1 over 2 UT minus 1 over 2 GT square. So yes, we have SP and SQ both there. So SQ, I'm writing it again, 1 over 2 UT minus 1 over 2 GT square. Now, listen. So this is the distance traveled by P, and this is the distance traveled by Q. So distance traveled by P and the distance traveled by Q. What I can do next? So SP plus SQ is equal to H. Obviously, the distance traveled by P and the distance traveled by Q, if you add these two distances, we have the total height, which is H. So just plug in the values 1 over 2 gt square plus 1 over 2 ut minus half gt square is equals to h. And h value is here u square over 2g. U square over 2g. So this goes with this. And the next step is 1 over 2 u t is equals to u square over 2g time cross multiply. So this 2 is here, 2 over u, and right hand side was u square over 2g. When you simplify, t is u over g. This is the time taken. This is the time between the instant when q is projected and the instant when the q, the second particle, when the two particles collide. So this is the time when the two particles collide. U over g part 2 is the time. And the last part is find where the two particles, so means the height where they to collide. So we need to find that height. So for the height, you can use either SP or SQ, any one you can use. So keep in mind that H we have calculated, it was equal to U square over 2G. It is U square over 2G, and yes, we use this in the second part. This is the height, and P is now coming down and Q is moving up. So obviously Q after reaching the maximum height will start moving in the downward direction. So next is find the height where the two apart. So height, for the height, either you can use SP or SQ. Anyone you can use, any one expression you can use either SP or SQ. Now, using in SP, this is short expression, 1 over 2 gt square. 1 over 2, 1 over 2 gt square. So 1 over 2, g is g and t is u over g whole square, which is 1 over 2 g u square over g square, and which simplifies to u square over u square over 2g. Oh, this is interesting point here. U square over 2g. U square over 2g was the maximum height. This was the maximum height. So it means that the particle which is coming down is now at point O. So we use this information that like for the working initially we're not sure about the position of P or the position of Q. So after calculation we got to know this thing that the distance traveled by P in the downward direction is again U square over 2G, which is the maximum height. So U square over 2G. So this which is equals to H, which is equals to maximum height. This is equals to maximum height reached by P. So from here you can conclude that the question was find the find where the two particles collide. So I can write a statement. P and Q collide at O. O means collide at the point of projection. That is, they collide at the point of projection. So this means that this particle started from O, it reached P particle started from O and it reached the maximum height and coming down. So this particle, the other particle started from here at at that time when P reaches the maximum reach the maximum height. So obviously it will move forward in the upper direction and then again will come down. So they will collide at point O. This is basically the uh, answer to this part. So P and Q because U square. If you find also, yes, for the understanding, what you can do, SQ, you can find SQ. SQ is half UT minus half GT square. Half UT minus half GT. Half UT minus half GT square. So when you use this value of T equals to U over G, U over G, so 1 over 2, the value of U is U and the T is U over G minus 1 over 2 G U over G square. So it is 1 over 2 or U square over 2G. When you simplify, it is again coming as U square over 2G. So equals to 0. So means SQ is equals to 0 means the particle Q is at point O. So they collide at point O.